sodium bicarbonate or baking soda to it. And we also add lime, calcium oxide. This is calcium oxide, calcium and oxygen. We add the calcium oxide and the baking soda, the sodium carbonate. Add them all to this small amount. We don't add that much of it. Add small amounts to the quartz glass, to the silicon dioxide, the melted silicon dioxide, and you will get the glass that we have in our windows and in our soda bottles and all kinds of things. This is our standard glass. It's what they call soda lime glass. This is the baking soda. This is the lime. So, soda, lime, glass, soda lime glass. Got it? Okay. So again, this is found all over the place. Glass is made flat for windows by pouring it on a pool of molten tin. We have a melted tin, which is a metal, and that doesn't really make waves as much as water would. So you have molten tin. You take this molten glass and pour it on top of the molten tin. The glass will, I guess, freeze or harden faster than the tin. And we pull up the glass, and we have a really, really nice flat plane. That's where we get our flat glass windows from. We take this soda lime glass and we put it on the tin. The thing is that maybe certain manufacturers of this will have tin with impurities on it, and they'll get into the glass. We might be able to identify where the glass came from based on these trace materials that got into the glass. By the way, they were made of the molten tin. Okay, again, this is just a possibility, but just telling you how the glass is made. Very often we add this boron trioxide. There's the boron, the B, and the oxygen is the O here. So we add boron trioxide to it. It'll make the glass heat resistant. This is used for cooking, laboratory glassware. It's we know it as Pyrex. You might be again. There may be other things that you go to your kitchenware store. You'll see basically glass cookware. What they do is they take the ordinary soda lime glass and they add this boron trioxide to make it heat resistant. Also, we'd like to do is we temper the glass. It's made what they call an annealing process. You heat it and cool it right around, not exactly at the melting point, but right around the melting point. So we heat it and cool it, and this makes the glass hard, or makes it hard to a certain extent. But what we do, we anneal it in a way to make it what we call tempered glass, which is used in the side windows and the rear windows of cars. It fragments into small pieces so that it's not nearly as dangerous when cars crash. If you'd have pieces of glass that are the size of your arm or your head flying around, that's dangerous. You find, however, you might have noticed it when you see the automotive glass breaking, it shatters into small, marble-sized pieces. That's a lot less dangerous. So that's why it's made of this tempered glass. There's a way of annealing it, by the way, to make it nearly bulletproof. Again, you need a lot of glass for that. But again, there are different procedures. But the annealing process does make tempered glass. That's what we're working with here. We have the car windshields are a little bit different. We do want them to fragment into small pieces, but we don't want them to fly around after they're small. So what's done is they're made of this tempered glass. It was annealed in that way, but we have plastic in between the two, so that even though they'll shatter, but they'll still stick to the plastic. So I say they fracture. They don't shatter into several different pieces flying all over the place. They'll fracture into tiny pieces, but they will not fly all over. This is called laminated glass. And there are other glasses that are made for house windows that are made. They may be designed to withstand things being thrown at them. They have, let's say, a certain amount of plastic in there. Different glasses are made for different purposes, and they're made in different ways. But these are the general ways in which they're done. So we can identify glass or by what the glass is made of, by analyzing what the glass is made of. Now, this would be a class characteristic because glass comes from companies. Companies makes all kinds of batches. So you might find one batch of this glass ended up in 50 different places in one city. So it's a class characteristic. It does narrow things down, but it's not an individual characteristic. But the point is, different glasses are used for different purposes and are made in different ways, and we can identify them by their properties. They have then the main properties that we use are the density and the refractive index. Remember, we dealt with density, that's the mass divided by the volume. The refractive index, we send light through it. Okay, so the way to get an individual characteristic from glass is to fit glass together. This is done not just for, let's say, a window that we suspect somebody shattered a window and so a piece of glass ended up on that suspect. So we match that glass to the broken glass of the window, and we'll say if it's a match, okay, that's individual. That's an individual characteristic, and we know this person with this glass and only this glass was at that, was in that place and was at the crime scene. It's not common to do this. By the way, it's not just for windows; it's for bottles. Let's say a bottle broke and a piece of the bottle ended up on in the car of the suspect. We match that to the original bottle that we know was at the crime scene. So again, we could place this person specifically who had this or this car specifically and only this car. This car at the crime scene, or it is connected to the crime scene because it's individual characteristic. Only this one piece of glass, and only this one piece of glass has the exact contours to fit the glass at the crime scene. So the thing is, it's not common to find this. It's done. It can be done, but it's not that common because often glass shatters into thousands of pieces. Finding the one piece to match the other ones at the crime scene is very hard to do. Also, if the suspect has this glass, we also have to assume the suspect didn't break his own piece of glass so that it can be matched to the original. So it's not a common thing, but it is done, and it can be done. And this is like one of the best pieces of evidence to get from glass because it is an individual characteristic. Generally speaking, we use the other characters, the class characteristics. The fact is the chemical composition of a given type of glass is usually the same. Maybe the trace elements are not, but that's a different story. We're just going to talk about the class characteristics. Finding individual characteristics is very hard to do with glass. Okay, so one of the properties that make a glass or a specific kind of glass, and how you can identify which class of glass it is by its density. It's one of the two most common forensically valuable properties of glass and the most common forensically studied properties of the glass to identify it, or to identify the class that it's in, or let's say the one who manufactures it. One of them is density, the other one is the refractive index. How do you get the density? The simplest way is to take the mass, weigh it, and put it in a graduated cylinder, see how much the water rises. That'll give the volume. Divide the mass by the volume, and you'll get the density. And you look on your list of densities of all different kinds of glass, and you'll see which kind of glass this is. If you find, let's say, you go to a suspect's house and you find a piece of broken glass, well, you take that glass, get the density, and see if it matches the density of, let's say, the house, the crime scene the house with the crime scene where there's glass there. If it's the same kind of glass, we'll start saying, hey, there may be some connection. Of course, it's only a class connection. He might have just gotten glass from the same place the other guy got where the crime scene place got their glass. Doesn't prove much, but it proves a little bit. It does connect the two to a certain extent.